Uh, Hi, I'm Philip Blackwell. This is my Math 2000. I think it's the third video. I don't know. Okay, so I have to find the area of an ellipse. So I'm going to take the integral of this equation, but I have to get it in terms of y. So you just use algebra and you move. Subtract this to the other side, multiply by b squared, take the square root, all that, and you get this equation right here. And so then what you do is you take the integral of this, and since an ellipse isn't really one of those functions where you can take the integral of the whole thing, the inside, you have to kind of cut it in half. I'm going to cut it in fourths though, because that's just what I'm going to do. And so I'm going to multiply this whole thing by 4. And it's going to go from 0 to pi over 2. So I'm going to take the integral from 0 to pi over 2 of this whole thing right here. And if I multiply this inside piece by a squared, it'll look like this. Which means x would be sine a sine of theta, and dx is going to be a cosine of theta. And so what I'm going to do is substitute all that in, so you get x over a equals sine of theta, and so you just plug all that in and you get sine squared of theta times your dx, which is cosine of theta times d theta. And you can move this a over here to the outside just to make it easier. And then you can substitute this for cosine squared of theta, and then so this becomes the square root of cosine squared theta times cosine theta d theta, and the square root and the square cancel out, and so what you're left with is a cosine squared of theta. And then what you're going to do is you're just going to integrate this, and so what you're going to get is no, you're not going to integrate this, sorry, you're going to substitute this out for the identity cosine 2 theta minus 1 over 2 plus 1, sorry. So you're going to, and then you'll integrate this, and so what you'll get is integral for the integral from 0 to pi over 2 of cosine 2 theta over 2 plus the integral from 0 to pi over 2 of 1/2 d theta. And when you integrate that, you're going to get 1/4 sine 2 theta plus 1/2 theta, all multiplied by 4ab, and evaluate it from 0 to pi over 2, and you can simplify that down. You get the 4 over 4 canceling, and so you just get ab sine of 2 theta plus 2 theta, 2 ab theta, sorry. And then you get 0 to pi over 2. Okay, and so then you evaluate this at from 0 to pi over 2, sorry, and so you get ab sine of, that just becomes pi plus 2ab pi over 2, which just sine of 0 plus 2ab times 0. And then sine at pi is 0. So this makes that 0. And then plus you get your ab pi. And minus sine of 0 is 0, and anything times 0 is 0. And so what you're left with for the area of an ellipse is ab pi.